Okay, for the next half an hour, we will have a short presentation about with the following subject of BIM for infrastructure in Finland. My name is Petri Louhi. I am a software specialist here at Civilpoint, and I'm going to be talking to you about the BIM for infrastructure in Finland. The slides are created by our CEO, Thomas Hörkkö, who wasn't unfortunately able to participate in this webinar today. Okay, first of all, short disclaimer. Since we are a Trimble reseller here in Finland, we need to show this disclaimer before all of our presentations that are to do with the Trimble products. So please do not make any purchasing decisions based on these demonstrations. Okay, Civilpoint is a Finnish-based company. Our slogan is software that build the future. Basically, two goals. One is to provide versatile and easy to use software for our users and customers. And the second part, which is very important as well, being able to help our customers with the usage of the software. This is with regard to training and deploying all of the different parts of the software into the daily usage for our customers. And as said, we are an authorized reseller of Trimble and Autodesk software here in Finland. Our main products are Trimble software, which is to do with planning, construction, and maintenance, and also for Autodesk products. Autodesk products are very closely used with regard to the design application provided by Trimble for a very wide range of applications for effective planning. Okay, first of all, I'm going to be going through a couple of slides with regard to the subject of BIM in infrastructure in Finland, and then we are going to be taking a look at the Trimble software with regard to the data management and especially with regard to railway design. Okay, so why BIM-based projects? BIM in infrastructure in the infrastructure in Finland has been very much growing in the last few years. There are a couple of really interesting aspects with regard to the BIM in infra. Productivity and innovations that is very closely connected to the seamless data flow in different projects. There are a lot of different benefits when working with BIM also on the infra sides, and these will have been proven to provide higher quality for the designers and as well as value for the money. One of the big questions is when the BIM is used also on the infra sector, there are a lot of aspects of being able to provide the solution that is also good in the aspect of different requirements, as well as, for example, on the customer side, how they are delivering these projects. Different requirements and different formats will vary from country to country, as well as the documentation that is provided within the design. Data management is very important in all of the life cycle of the project, starting from the early design process, planning phase, and continuing until the maintenance in the process. Training is obviously needed when starting to use different software in order to use the BIM process in design. In Finland, the requirements that are in which have been adapted on the infra side are called these common infra BIM requirements. originates from 2015, in which the first versions of these requirements were taken into use by the customer, which is the traffic transport agency, mainly in Finland, and it has to do basically with three things that you can see on the right side of the slide. First of all, you have the requirements, and the requirements consists of different documentation with regard to the different parts of the project that the design is used. Then about the format, the green button, which means the inframodal data exchange, all of the things that are used between different softwares, and also the format that is used when the actual project is then delivered to the customer. That has to do with the settings and definitions about the data exchange. The inframodal is a format used in Finland, which originates from LandXML, and on top of LandXML there are additional features and usage of the things that are described in LandXML, and also additional features that are defined on top of that. And the third aspect of these requirements is the classification system, which will then tell the user how the things need to be coded in the model, and what kind of deliverables are then used to comply with these settings of the model. Okay, so where are we going? And if you look at this slide, we have started from 2D drawings on the left, and then we have moved on into 3D models, and from there into the 3D collaboration models, where the data flow is a bit different compared, for example, to the amount of users in the model, and also details about the data. And where we are going, or where we at least should be going, would be towards level 3, which would be then more integrated solution, where all of the different disciplines would be available in the same model. Everybody should see real time the same information that is available in the model exactly at the time when the user is looking at the model. This will not, of course, lots of people still use, of course, 2D drawings. These are the official deliverable, at least in many cases, at least still in Finland. But we're trying to move into the kind of paperless data flow in which everything would be model based. And as said, the customer, the Finnish Transport Agency, and the other big owners, big cities and municipalities, they have a demand for modeling. This is the most important thing about being able to use the BIM in infrastructure. You need to have the big owners ordering BIM-based solutions in order to be able to design more effective. And since 1st of April, already in 2014, everything is required to be delivered within this inframodal 3 format. For the infra part and structural engineering, the format of the deliverance is IFC. All of these requirements are updating constantly. For example, now we're working with the inframodal 4 version of the standard, which will then be used starting from 2018 spring. This is the way that these demands are moving on in Finland. Okay, a few lessons learned about from Finland and abroad. If we take a look at the BIM BIM in project lifecycle is it's very interesting to see, or there are a lot of different aspects with regard to when a process of the design is started with the conceptual planning and going there into more detailed planning and then construction and eventually into maintenance. There are different aspects in all of these cases, but the idea of having the information more rich when it goes beyond one phase and towards the next one, so that no data would be lost during the life cycle. And where's the actual value of the BIM approach in the project? In this slide you can see that the number of projects in total with regard to the small projects and medium and big projects, there are actually value in all of these cases. There are lots more small projects than of course than the big projects, but still the value can be found in all of the projects where the BIM is used. And also with regard to the size of the project compared to the budget and the result, you can see that the size of the project not necessarily is actually the one that gives the most money back value from the usage of BIM. And also sharing the best practices from mainly from the process point of view is very important. There are different aspects if you compare the customer side and also from the designer side and from the owner side. These things are something that are developing constantly. As said, the requirements and standards, they are developing all the time. But and also the modeling has to be a part of the design, not a separate phase of its own, and that's why all of the different domain design disciplines software is also going into that direction. User should be always able to look at the modeled view from the project and not separately create something that will then produce the result of the modeling. And then also when sharing practices from the modeling point of view, modeling should be started at the very beginning of the project and continue up until the end. Different benefits can be found on the way. Maybe also something that are not cannot be seen in forehand, but when everybody is viewing and seeing the same model, then these benefits will be more clear to all of the parts that are using the same model to view the process and the modeling where the design is used. Okay, a few slides about that. Please contact us for more information if you need. And then also as a last slide, this is the construction continuum provided by Trimble. And with regard to all of these different aspects that the slides were about, this is kind of the continuum and Trimble's vision about the life cycle of the project and of the data, especially the data where it starts from the feasibility analysis and moves on into the different parts of the project, going from conceptual and detailed design up until the construction where something actually is being created, and then from where it goes back to the customer and the owner, who is then operating the data and seeing the data and taking care of the full life cycle of the data. Okay, that was about the slides. Then we will we'll be going to. I will show you a couple of examples about about the software. I'll be moving into NovaPoint base. As said, during the construction continuum, the data is really the most important thing to handle. And on Trimble solution, we have the Trimble Quadri data model server. And now this is the NovaPoint base, which actually has now the view into the data that is located on the data model server. The data model server is a cloud-based service, Oracle database, which will then handle all of the data and then show the information through this base user interface to all of the participants that are working in the project. This project in question is E6, a little bit northbound of Oslo, an actual project which is now, I guess, on the construction phase. This is a kind of a demonstration model about the different disciplines that are used to create this data set. I'll be showing you a couple of ready-made presentations. These different views are called presentations that are actually just showing the required part of the model in which user then can move freely and view different things that are available in the model. On the left here you can see the process model, which is then called. This is also to do with the different requirements. This is a bit different compared to different market areas in Finland, for example, with regard to these common infra BIM requirements. There are certain kind of process model that our users try to follow when adding different things on the model with different tools. Then we have the view area in here, and also different presentation setup, meaning that I can disconnect and connect different parts of the model in order to see, for example, what's happening underneath the road and rail plan, in order to see more clearly, or then I can just create additional views that I want to see in the project. Okay, everybody who's using the same data set will download one set of the data, which is called work set. Everything that is now seen here is real time. If I want to update my work set, I can do it from here. Then I can see everything that is changed from the data model server, and then update all of the information, so I can be sure that I'm also always working and seeing the latest information about what other users have been creating. In this case, the construction model is separated into client and owner, contractor, and the actual part where you can see all of the design. And now if we are going to look at the railway design, we can see that, okay, we have two tracks in here which has been then added into the domain models part, and domain model rail will contain all the information about the railway design in this model. This process model is of course totally user or organization definable, to be able just to structure the information so that it's easier to view and see than in the model. The railway design if we think about Trimble solutions, the railway design is you can see different tasks in here which are then created in order to do the design required in this case. Railway design has basically two main things: the alignment design and then the actual railway modeling, from which we can see the examples in here. With regard to catenary design, there are also functionality that user can find the correct location for the catenary masts, and also the overhead lines and the bracing wires with regard to the electrification of the track. And then these symbols can be created, for example, from just the DVG files and then import back to the model. If we take a look at, for example, this very model in question, it's now called this model 80101. The model is not sorry, let me go back from there. The model is not reserved for me, but I can still view the contents of the model and view the model in different views. If I go into editing the model in here, we can see that we have lots of basic data which is used then to create the model, and then we can see the results of the design in here. For example, if I want to go to see the cross sections from this model, I can just open the cross section view from the model, which is then using also lots of other different information with regard to, for example, the catenary design as the input, or showing actually all the results of the catenary design also in the same model. Model consists of different surfaces. User can also model the clearance of the track that can be seen here, and also other parts of the model, for example, with regard to the structures that can be viewed within the design. All of these things are something that are affecting the design, so that these needs to be available also for the user. As said, model can be viewed in just in cross section, or then if I want to just view only that part of the model, only one track, I can select that to be seen in just 3D view. So then now the model looks for example like this. Railway alignment design. What is done before the actual modeling of the tracks is done on AutoCAD side. On AutoCAD, we can use some of the tools that are used, for example, in railway design, and for example, the alignment design tool is something that will be then used on top of AutoCAD. We can use different options in alignment design, and then these information from the alignment design will be saved to the model, back to the model in which the railway modeling is then done. Okay. Also, if the railway modeling is not done in NovaPoint but in some other software, user can then use different methods of getting the information into the model. On the import files part, we will have there are different options to input more data into the project. For example, if land XML surfaces or something is created on top of the drawing files, all of this information can be added into the project, and then seen like the other elements that are added directly with the different discipline design solutions that are done directly inside the base system. So when something has been added into the model, it can be shared back to the data model server, and then anybody who is using this project can update their own workset by the receive command and get the same information available also to their own worksets. Then communication is also very important part of the process. One way to communicate is through the base system, where you can have different topics, meaning that different kind of conversations that are carried out through the model. For example, if I want to add a new topic, I can do it from here, or then I can go into some topic and see that what a certain user has added into the model. I can zoom into the location and see that some discussions have been started inside the model in order, for example, to see the different status and for example, assign different tasks within the model. These views and these topics are very often used between the interactive discussion of, for example, the construction on the construction phase by the constructor and then the designer to discuss the different aspects of the model in order to, for example, see maybe some errors in the model, and for example then change the status of different things that are then discussed over the topics in the model. So that's very powerful also to be able to actually have a discussion around the things that are included in the model, and then also use that as kind of a work list in order to get things corrected in the model, because the model is real time. Everything that is done and shared to the model, it will be visible also for all of the users that are available in the model. Also, if user is not using the base system, there are a couple of other ways of being able to use the software. One way is to use this Novapoint Viewer, which is an application that can be installed, for example, next to the base system, which is only a viewer in which you can only view the data but not edit anything. And then other option is to just use web browser. For example, if I just log into after Firefox has been installed the latest update, so I can go into the web browser and log in. Okay, let's say. And now I can go into the web browser and see the same data set also over the website. So I can now see what has been happening in the project. I can see the project location, and also I can see the same topics and discussion also here in the web browser. So it means that every presentation, also the 3D views that has been shared into the model, can be seen by someone who is not actually without someone having to install actual software in order to see different presentations that are then used in the model, for example, in order to participate in the discussion that are happening inside the model. Okay, I think our time is up. Okay, I had a question: are these common BIM requirements used in railway projects? Yes, the BIM requirements are used also in rail projects. The only difference, if you compare road to rail, is basically something in the classification that says that, okay, now we have, for example, the topmost surface of a rail track and not a road. But the same requirements with regard to the things that the user designer needs to deliver, they are the same for railways also. Okay, so if there are no more questions, thank you for your time and attention, and please do get back to us if you have more questions even after this webinar. But thank you very much for your time.